So now let's try it for a circle. X squared plus y squared equals 3 squared, just because not everything has a radius of 1, right? Or you could call that 9. So it's a circle like this that goes to 3 there, minus 3, minus 3, and 3. And maybe we want to know the slope of a tangent line there. Which we could say is dy over dx. So we want to find dy over dx, so let's take the derivative with respect to x on both sides. So we'll get dx of x squared plus y squared equals dx of 9. This is dx of x squared plus ddx of y squared equals 0. What's derivative of x squared with respect to x? That's just 2x. What's the derivative with respect to x of y squared? It's not just 2y. That would be if it was dy y squared, but this ddx x squared y squared. So we're going to do the same thing we did up here. Got to use the chain rule. So actually we could just copy the result from up there. Let's say 2y times dy dx equals 0. So now all the calculus is done. I've taken derivatives. I know it seems like I don't have an answer here, but that's just kind of the name of what I'm looking for. And then we'll use algebra. What would you do here? Subtract 2x from both sides. And then you'd have 2y dy dx equals negative 2x. Then divide both sides by 2y like we did before. And then let's do the answer up here. So then what do we have? dy over dx equals negative 2x over 2y. Let's stop and think about that. What is that saying? Well, first of all, for example, if x and y are equal, then I'm kind of on the 45-degree line here, and I would just get a slope of -1. Does that make sense as the slope of the tangent line to a circle when you're on the 45-degree line? I think that works out okay. But another way to look at it is, now you can't really do this with fractions formally, but informally it's fine. If I look at this top and this bottom, what do I see? I see dy is like negative 2x. And dx is like 2y, which is saying dy is basically proportional to x. And dx is proportional to y. Where have we seen that before? That was in the very first part of this chapter, where we said something is moving around and its movement in y and x depend on its current x and y value. And in Scratch we got basically a circle, and now we kind of see why. We can get more detailed and say, let's kind of zoom in on part of the circle there, and we're starting here, let's say, and our dy and dx lead us to go in a particular direction. So we step in that direction and end up here. Notice we just landed a little bit off the circle, a little bit farther out than the circle. And then if we did it again, we'd be kind of going, supposing we're on a circle with a slightly higher radius, and then we'd step again and we'd end up a little bit off that circle even, and that's why we were seeing the spiraling. So we could see less spiraling if we took smaller steps each time, or if we're more careful about updating delta y and delta x each time, like I said in the other video. All right, one more video to go.